In this pod, we'll look at investigating the current voltage characteristics of a component.
Before you start this investigation, you need to remind yourself of some basic ideas about electricity. In chemistry, you will have learned about the structure of atoms. You'll know that atoms have a nucleus, which consists of protons and neutrons. There are electrons outside the nucleus. Neutrons are, as their name implies, neutral and do not have an electric charge. Protons, however, have a positive charge, and electrons have a negative charge.
If an atom has an equal number of protons and electrons, it is said to be neutral. However, if there are electrons missing, and therefore more protons than electrons, the atom has a positive charge. Similarly, if there are more electrons than protons, it has a negative charge. Positive charges and negative charges attract each other and try to move towards each other. The symbol for electric charge is Q. Charge is measured in coulombs.
If opposite charges are connected by a material which conducts electricity, a conductor, the electric charge will flow through the material. The rate of flow of charge is called current. Current has the symbol I and is measured in amperes or amps for short. A current of 1 amp is a flow of 1 coulomb of charge per second.
You can work out the current through the equation I equals Q divided by T, where T means time and is measured in seconds. A volt, symbol V, is how much energy in joules each coulomb of charge is carrying. 1 volt is 1 joule per coulomb. You can work out voltage through the equation V equals E divided by Q, where E is energy. Voltage can also be referred to as potential difference.
Resistance, as the name implies, is a property that tries to slow down the flow of charge. Resistance is measured in ohms. The relationship or formula between potential difference, current, and resistance is that potential difference equals current multiplied by resistance, or V equals I multiplied by R.
The amount of resistance a material or component has depends on things such as its composition and its temperature. In this investigation, you're going to look at how voltage affects current for various components and relate this to the resistance of the component. First, you will need to set up your circuit. You'll need
a DC or direct current power supply, which will deliver a 12-volt supply. A variable resistor to control the current in the circuit that contains the component to be tested. An ammeter placed in series to measure the current. A voltmeter placed in parallel with the component to measure the potential difference across it, and the component itself.
The circuit is set up as shown. You can connect the components using a circuit board or with connecting wires and crocodile clips. To start the investigation, first draw a table with 2 columns. Label one column potential difference and the other current. Voltage is the independent variable, the one you set yourself. Current is the dependent variable, the one you read.
Let's say that in your first experiment, your component will be a fixed resistor. Using the variable resistor, set the voltmeter to read 1 volt and read the current shown on the ammeter. Enter the results into your table. You can start to plot a graph with voltage on the x-axis and current on the y-axis. Your final graph should look like this.
The straight line passing through the origin shows that the current increases in direct proportion to the potential difference. If you reverse the connections of the power supply so that the current flows in the opposite direction, a combined graph would look like this. This graph shows that current is directly proportional to the voltage in both directions. This reveals that the resistance value of the resistor remains constant.
We can repeat the experiment to investigate the resistance of a filament bulb. Replace the fixed resistor in the circuit with the filament bulb. This new experiment would give you a graph like this. Here we can see that the current through the filament bulb is not proportional to the voltage. In fact, the rate of increase in current has decreased as the voltage has increased. Another thing you'll have noticed is that the temperature of the filament in the bulb has increased as the voltage increased. You can see that the bulb is glowing brighter. It can be concluded that the resistance of the filament has increased as temperature has increased.
You can also do the experiment using a diode. A diode gives you a graph like this, showing that the current is only flowing in the positive direction. From this part of the investigation, it can be seen that a diode allows current to flow in only one direction.